Okay, problem 3 has a little bit more going on in it, so it's a very important one for us to go over. It says the demand for a function is d of p equals negative 3.5p plus 45, and the cost function is given by the following. It costs $1.80 per item with fixed costs of $72. So the first thing that I notice is that I don't have a cost function. I have to write it. I've got information, so I can write it. It says that it costs, so we're going to have a cost function, $1.80 per item. Now this is the first tricky part here. Item, is that price or is that quantity? Well, an item is a quantity. So this is saying it costs $1.80 per Q with fixed cost of 72. So my independent variable here is Q. If I know the quantity, then I'll know the cost. So my function is $1.80 times the number of items plus $72 in fixed cost. Okay, so we want to write a revenue function. Well, when we come up here, we see that your demand is in terms of P. So I have an independent variable here of P, and I have a cost function where my independent variable is Q, and so you can see why this one's a little bit harder. So what we want to do is I want to use P as my independent variable because my demand function is in terms of P. So P is price, of course, and it's going to be independent. And again, that means that every function that I write has to have P as my independent variable. So my revenue function is going to be R of P, and that's P times Q normally. But since P is independent, my Q has to go away, and that's why I chose P to be independent. So I'm going to replace my Q with negative 3.5p plus 45. So R of P equals negative 3.5p squared plus 45p. So that's my revenue function. Then B says write a cost function, and I immediately went to that. That was the first thing I noticed this time in this video. So I'll just write that down again. And so again, you can see that P was independent from my revenue, and that was because revenue uses the demand equation, and the demand equation had P as my independent variable. But cost is in terms of Q. So that's why this problem is so important, because now I want to write a profit function, and at the very beginning I said P was going to be independent. So my profit function is going to have P be the independent variable, the price. And so I need revenue minus cost. Well, remember, this has to be an R of P function, and this has to be a C of P function. But I don't have a C of P, I have a C of Q. So it's the same way we did revenue. How could I make this Q go away and become a P? I need to make this a C of P function. Well, again, the demand equation is Q equals negative 3.5p plus 45. So just like before, when I get to Q, I'm going to write the demand equation. And that's going to give me C of P equals 1.8 times negative 3.5. And that's negative 6.3p plus 81 plus 72. And so C of P equals negative 6.3p plus 153. So now I have a cost function that's in terms of P. So now I can write my profit function, and the revenue is negative 3.5p squared plus 45p. Remember how important the parentheses are when you have a minus in front. And so my profit function is negative 3.5p squared plus 45p. Distribute the negative, and that becomes a positive 6.3p. Distribute the negative, that becomes a minus 153. So the profit is negative 3.5p squared. Like terms, 45p and 6.3p give me 51.3p minus 153. So there's my profit function. To find the break-even points, again, that occurs when the profit is equal to 0. Remember, a negative leading term quadratic is going to open upside down, so you'll have 2 break-even points. So you will use Excel to do that, or you could use the quadratic formula. And then just a little extra, we'll answer this when we go and look at Excel. If profit is to be $20, what must the item sell for? But algebraically speaking, what that means is you are setting this profit function equal to 20 because profit is 20. So again, you could use the quadratic formula, set this equal to 0, and then use the quadratic formula. But we're going to use Excel. Okay, so problem 3, starting out, P is our independent variable, and so Q is going to be column B. I'm going to call it demand Q. Now honestly, I probably, if I were doing this problem, you can peek and see, well, I need profit for break even, I need profit for question, this should be question E. But if you go ahead and get in the habit of typing in revenue and cost and profit, and using all of those columns, it's not going to kill you. And my suggestion really is to use the Excel's power. So I'm typing in the demand Q equals negative 3.5 times A2 plus 45. And then revenue, honestly, I would not type in the algebraic equation. I don't need to. I know that Excel is going to build an equivalent function, so I'm just going to type in P times Q. And my cost function is, this is very interesting. So if I wanted to type in this by hand, I would not, I could type in 1.8 Q plus 72, but I would need to click on the Q here. And there's no problem with that because this, remember, this Q in this column is referring to P. So when I type in 1.8 times, excuse me, let's see if I can do better. Click on this cost. If I type in 1.8 times this Q plus 72, the cool thing is Excel is actually writing this function in terms of P, because B2 is right here, and this B2 refers to A2 as the independent variable. So you can use the capabilities of Excel to do all this algebraic work. Now remember, the reason that you're doing all this algebraic work is for Unit 2 when you have to take a derivative. So I hope that makes sense. You really have to be honest about this. You have to learn how to do this algebraically, but you can use the power of Excel. Okay, so instead of typing in this quadratic where I may have made a mistake maybe, I'm going to use the power of Excel and just do revenue minus cost. Again, this is tricky for you, I know, because you don't know what's coming. But if this were a Unit 2 question and it said, like, what's the maximum profit, then you would need the derivative, and Excel won't do the derivative. So you would have to know how to take the derivative of an algebraic function. But bottom line this is how I would do the problem if it were me. I would do all this work for the test's sake. You need to show all this work. But then when it came time to use Excel, I would let Excel build my revenue function. I would let Excel build my cost function in terms of P by clicking on Q. And I would let Excel build my profit function by clicking on revenue minus cost. Okay, so now it's time to figure out my domain. And again, I'm looking for places where profit goes from negative to positive. And it's going from negative to positive here between 4 and 5, and it's going from negative to positive here between 10 and 11. So I only need my domain to go from 0 to 11. I'm going to graph it. You may think, I don't need to graph it, I already see what's happening. I always encourage you to graph. Again, some things are going to happen in Unit 2 where that's going to be important. So here's my graph. It's what I would think it is. And so now I'm going to goal seek. And I'm going to put guess points of 4 and 11. And I'm going to go to data, what if analysis, goal seek, finding the break-even points, what I'm doing. So profit's going to 0 by changing cell A4. Do the same thing for my second value. And I'm using text boxes so because I don't want to go back and videotape my paper, but I want you to know you would not use text boxes on a test. Everything that you turn in is going to be written on a paper. So I'm typing these answers, but you would want to write them. So the break-even points are, this 4.17 is price, so $4.17 at 30.41 items, and the second break-even price is $10.49 at 8.29 items. I'm just rounding to the hundredths place here, first of all, because this is money, so that's obvious, and here rounding to the hundredths place because it's convenient. Now, I don't care about these decimals, that's fine. I want the answers just to be decimals. We haven't done very much of this, but there'll be times when it says at the beginning maybe that items are in hundreds. So if this were items in hundreds, it would be 3,041 items. But as it goes right now, you can just round to the hundredths place. Okay, and the last question should be question E. If the profit is to be $20, what must the item sell for? So I can see that when profit is 20, it's right here on the y-axis. So this would be a horizontal line through 20, and you can see there's going to be two answers. And so, but goal seek will do the trick for us. So I'm going to pull down profit 2 more times, and I can insert, just so you can see, I have to guess where 20 is. So here's 25, so 20 maybe right here. I'm doing this so I can pick some guess numbers. And so a good guess number might be right here, maybe 5. And another good guess number might be right here, maybe 9. So I'm looking at the graph to pick out my guess numbers. And this time I'm not going to goal seek to 0, I'm going to goal seek to 20. So when the profit is 20, there's your price, $5.26, or let's goal seek again. $9.40. The profit is $20 at a price of $5.26 and 26.59 items, or $9.40 at 12.11 items. So again, you would write that on your paper. And that's the complete answer. I just reread the problem. It says, what must the item sell for? So technically, I would not count off if you left the Q values off. There.